Vectors, scalars, and mathematical operations involving vectors and scalars. Let's learn physics. I don't know about you, but I think it's just amazing. The measurements that we take can be split into two different categories. Everything we measure can be split into these two different classes: vectors and scalars. Vectors have direction. They have a physical direction in space: up, down, east, west. You can point to the direction of these things in space. And weight is an example of a force. So these two are similar categories. Your weight is always down. It's the force of gravity on you or on some object, always down. Forces, you push something in a particular direction. It has a direction in space. Velocity, acceleration, displacement, they're connected to each other, and they all, by our definition here in physics, have directions. Momentum, also, combination of velocity and mass, that thing has direction. And field strength, gravitational field strength, electric field strength, magnetic field strength, all of those have physical directions in space. On the other hand, most of our measurements are scalars. Most of the things we can measure do not have a direction. Both of these have magnitude, a number with units, but most of them do not have a direction in space. Mass, as opposed to weight, mass does not have a direction. It's the amount of matter in an object, the quantity of inertia, resistance to acceleration that something has. Speed, distance, our definitions of speed and distance are different from velocity and displacement. Length and width and height, no direction in space. Height, you think it's like up, but it's up and down. Does not have a direction. Temperature, it's not physically up or down. It's just a measurement without a physical direction in space. All energy, kinetic energy, even though you think kinetic energy is something moving, the velocity has direction, but the energy does not. Work, no energy, power, none of those things have direction. They're different from momentum. And the conservation of energy is not related to direction. Conservation of momentum, direction is important. Voltage and current and resistance, that electrical stuff, not related to direction. But the electric field strength does have a direction and will apply forces to charges. Charge doesn't have a direction. Most of the measurements we make in physics don't have a direction. So keep that distinction in mind. These have magnitude and direction. These have magnitude only. Number plus units plus direction. Number with units. And to make it more complicated, operations are different too. For addition, subtraction, multiplication, and division, it's pretty simple with scalars. Scalars are just like regular numbers. You put the units on it, you carry the units through, you add 5 kilograms plus 3 kilograms, you get 8 kilograms. You subtract in the same way. Multiply and divide, just hang on to the units. 10 miles per 2 hours. You travel 10 miles in 2 hours, that's 5 miles per hour. That's pretty simple stuff. However, the vectors, the direction complicates things quite a bit. 5 newtons plus 3 newtons, both in the same direction, you get 8 newtons in that same direction. And 5 newtons this way and 3 newtons that way, you get a partial cancellation and 2 newtons in the direction of the big one. And if you have 5 newtons in this direction and 3 newtons in this direction, you would get something like this, depending on their relative directions. And you can do this a bunch of different ways, but 5 newtons and 3 newtons, if you draw that to scale and draw that to scale in the proper direction, then connect the two, you get maybe 6.7 newtons at 21 degrees above that x-axis. It gets pretty complicated, and that's just addition. Subtraction is just adding the opposite. Multiplication and division, much more complicated, far beyond the scope of a normal early physics class. So we know that we can add, subtract, multiply, and divide vectors and scalars. But can we put them together in the same equation and maybe add, subtract, multiply, and divide vectors and scalars together? Let's take a look. Vectors, adding and subtracting. 5 newtons to the right plus 3 kilograms with no direction. Yeah, you can't do that. That's like adding unlike terms. You can't add terms that are not similar terms. It's like 5x plus 3. Different terms with that vector. So you cannot add or subtract vectors and scalars. But multiplication and division, can you do that? Well, here's an equation. Net force is mass times acceleration. Here's another equation. Average velocity is displacement over time, and by their very nature, they have combinations of vectors and scalars within them. So 3 kilograms, scalar, mass, no direction, multiplied by the acceleration 5 meters per second every second to the right, gives you scalar times vector, a new number, a new value with different units in the same direction as the single vector. It works. So we can multiply vectors and scalars. What about division? Here's another equation. Average velocity, a vector, displacement, a vector, time doesn't have a direction. 12 meters in this direction as an example, 3 seconds, 12 over 3 is 4 meters per second, just do regular multiplication division, and then just hang on to the same direction. So you can multiply and divide vectors and scalars in the proper equation, and they're pretty common, and you cannot, none of this, no addition and subtraction of vectors and scalars together. These are the reference tables that I give my students, and if you notice that I do have little arrows underneath, they should be on top, but they were interfering in the diagram, so I put them underneath. But there are plenty of equations with both vectors and scalars. A couple of them you've seen already, but it's actually pretty common to have a combination of vectors and scalars in the same equation as long as it is multiplication. Like here you have a vector equals a vector scalar plus a vector scalar. So vector plus vector equals vector. As long as you have an addition between vectors, you can multiply and divide vector scalar combinations with no problem. Really important distinction in physics. Always keep in mind that you need to classify in your own brain whether a measurement has a direction or does not. Thanks for watching Learn Physics. And thanks for that thumbs up too. Really helps a lot. New videos most academic weeks. Subscribe for more. I've even got education ideas, Freaky Physics Friday, and Tech Tip Tuesday. And for bicycles, motorcycles, and family adventures, it's my other channel, Bike Physics. You just learned physics.